Hello everyone, hi again, welcome back to another video on Lead Code Coding series. So in this uh, given section of array data structures, we're going to solve a new problem that is, move zeros. So here, this is our problem, move zeros. Okay, so right now, what is the problem statement? Also, I will give the link in the description box of this question. So here it is given that we have an integer array nums and we have to move all the zeros to the end of it. Also, we have to maintain the relative order of all the non-zero elements. Okay, so just understand this example first. So we have an integer array nums as 0, 1, 0, 3, 12. Okay, so here all the non-zero elements should maintain their relative order. That means here we will first found. Okay, we will first found that one is the first non-zero element, so one should be at the first index. Okay, that is at index at first position. Okay, and again 3 is the second element, so it is as the first index, and same with 12. Also the remaining, okay, so the remaining value becomes 0. So all the elements that is at the end should be 0. So this is basically our problem statement. Also you can see this in this problem there are two parts. First one is that we have to move all the zeros at the end, and the second part is the non-zero elements should maintain the order. Okay, so in the second example we have only one element. Okay, so we just simply return that array. We don't need to update the value. So if the array size is 0 or array size is 1, that means we don't need to change anything. Okay, so if the array size is greater than 1. So just think about that situation. So we have an array 0, 3, 1, 12, and 0. I'm just taking an example. And how can we solve this problem? So we can solve this problem with basically optimal solution, because also it was given that in the note we don't need to use another extra array. So we will only use a single order of one extra space. So for that we can solve this problem with, okay, two ways that for the optimal solution. First one is that what we will do, we will simply put all the non-zero elements as their order. Okay, so that is 3, 1, 12. So here we will first found that 3 is the first non-zero element, so we will just put the 3 at first index. Okay, and for that I will use a variable p, and it simply keep the record of non-zero elements. So it was initially 0. So after that, when after that we will get again the non-zero elements, and we simply put that element after 3 and just increase that array index by 1. So here the next value is 12. We simply put that value at 12, and the array index is increased by 1. Okay, so initially it was 0. Okay, and then we will increase at by 1. So after that we will put the value 1, when an increase 2, and after that we will 12. So here we'll again increase the value as 3. So right now we have an array in this way. This is 0, 1, 2, 3. So there we have 12. Okay, so we have 12 and 0. Okay, so this is basically our array right now, because what we will do, we only put all the non-zero elements in the beginning. Okay, and we don't update the remaining part of the array. So for the first part we use a for loop. Okay, it simply runs from 0 to n minus of 1 if n is length, and we simply check if the value is not equal to 0, and we will just put that value, okay, inside the array. And also we will increase the array index p plus plus by 1. So this is the first part of this for this logic. And the second part, what we have to do, we have to make all the remaining numbers 0. So here we have already reached at that index. So we will again use a for loop from from p to n minus 1, and is basically array length, and we will just update the nums array. Okay, simply put the variable j where we store the value p, and it basically 0. So here we will use two for loop. Okay, so it is not nested. So first for loop basically gives all the non-zero elements at like in the respective index to maintain order, and after that the remaining elements should be 0. Okay, so we will just update that value with 0. So this is the first way of solve this problem, and it is also optimal solution. So here time complexity is order of n, because we have to just traverse each and every element. Also space complexity is order of 1, because we didn't use any array or other data structures. Okay, so simply use a variable to store index. So right now we're going to solve this problem by second way. Okay, this is also an optimal way to solve this problem. We have 0. Okay, so simply 0, 3, 1, 12, and it is 0. So here what we will do, okay, we will use the concept. Okay, so here our focus is that our main goal is that to put all the non-zero elements, like put all the zero elements at the last, and also we have to maintain the order. So here if we will get our first non-zero elements, that means we have to put that means we have to put that value at the first index. Okay, so since these two arrays are same, so here if we put 3 at the index 0, so we will get the value that is 3 3. But here we will not put that value at that index. So rather than put that value at that index, we will just swap. So we will simply swap this index with 3. So here it will become 3 comma 0. Okay, so as we reach at the first index, so here we simply increase the value p. So p index is basically was 0, and right now it is 1. So this index p, it simply keeps the records of non-zero elements, keeps the record of non-zero elements, non-zero elements. Okay, the index of non-zero elements. So after that, suppose we will get the second, okay, the next non-zero elements, array index should be 1. So we simply swap the value 1 with the value at the index 1. So what is right now the value at index 1? It is 0. So we will just swap this value with the value 0. Okay, so now it is 3 1 0 12 0. Right now we reach at this index at 12. So here also we have to increase the value of p, because we already covered two elements, so at index 0 and index 1. So here right now we have value 12. We simply swap this 12 with the value at this index. So it is right now 0. So we simply delete that value and just put here, we will just put the value 12, and right now simply there it is because we already swap it, so it becomes 0, and there we will get again a 0 element, so we will not do anything. Okay, so here what is the concept, that if we will get non-zero elements, okay, so if we will get any num0 value, that means in the if part we can write if nums of I not is equal to 0. This is basically our condition. So what we will do, we simply swap what the value at the index of p, that means nums nums of p with nums of I. So here you can see that we just focus to maintain the order of non-zero elements, and also we will get already like it becomes like it already all the zero elements becomes at the end of the array. So how it's happened, so here you can understand. So when we will get our first non-zero elements, okay, so our first non-zero element means all the elements before that must be 0. Okay, so when we will swap it, that means we will put that value like non-zero elements at the beginning and just put that 0 value after that. Okay, again when we get the next array index, and that means we just simply swap that value with the 0 value. Okay, so that swap value must be 0. Okay, so in this way we will reach at the last index and we will found that we already complete our array in this way. So it basically gives 3 1 12 0 0. So this is our second logic, and here also time complexity order of n and space complexity is order of 1. Now you can see the code at lead code. Okay, so let me first open the lead code, guys. So here what we will do, we will use a for loop to iterate the element. So simply int I is equal to 0. Okay, I less than nums dot length length and I plus plus. Okay, so 1 minute. Yes, length. So here what we will do, we will check if the nums value is not equal to 0. Okay, that is for the all non-zero elements, and we simply swap. So I'm not using swap functions, so we have to create a function swap. Also we have to pass array and also the index value. So we just simply swap that value here. So right now to swap two numbers, we simply use another variable. It is should be temp. So int temp is equal to nums of I. Okay, and there uh, nums of where we will put that value. So we will put that value at the index p. So p plus plus. So simply what is p plus plus? Int, I'm just using p as another variable. Int p is equal to 0. Okay, so here we will just put that value nums of p at, okay, the temp, sorry, the nums of I must be nums of p, the value at the index p. Okay, and at the nums of p, guys. Okay, we will just put that value temp. So here we just swap all those values and just simply return. Just gonna run this. Okay, so it is okay. 1 minute. I plus plus. Yeah, now it looks good. So this is our code basically. Okay, and thanks for watching, and if you like the video on lead code coding series, please do subscribe the channel.